All right. So this is a mole-to-mole continued. You guys already have this down. So I'll tell you guys when we start to do some new stuff. So remember, key thing, mole ratios are the coefficients. And so far, we've just done things with one reactant and compared everything else. So for this example, we need 1.5 moles of hydrogen to react with 0.5 moles of nitrogen by doing the ratio method. So same kind of thing with this one. This is just another example. So the key thing, all we've done here is we've had one amount of a reactant. So what happens if we have different amounts of reactants though? So this is new stuff. And if you think about these things, it's just as simple as making a bicycle. If you have 2 wheels and 1 frame, you make 1 bicycle, right? What if you have 6 frames and 4 wheels? How many bicycles can you make? Think about that for 1 second. So, how many bicycles can we make, Augustine? 2. 2 bicycles. Because I only have 4 tires. Tires up here. Okay? So, we have 2 different BRPs we have to set up for this. Because I have 4 wheels and 6 frames. Okay? So this is how to do this thing, this type of problem. It's called the limiting reagent problem. So let's talk about this example again. I have extra frames, right? I run out of tires here. I only have 4 tires. So I only need 2 of these frames here to make the bicycles. So what I can do is I want you guys to fill in this, write this chart down, and fill in both of them. And I will give you guys a couple seconds. So with 4 wheels, I need 2 frames, and I'll be able to make 2 bicycles. Correct? For 6 frames, I need 12 wheels to make 6 bicycles. Now, which one is going to be the true BRP? The top one or the bottom one? This is going to be my correct one. So here, I have this all diagrammed out. I have 4 tires, 6 frames. I make 2 bicycles, and I just have 4 frames left over. Tires are what they call my limiting reagent, because they limit how many bicycles that I can make. After I've reacted all the tires, I run out. I don't have enough tires to react with all 6 frames because I have 4, but I need 12. So I'm just going to have extra frames. So we can get rid of this one. The product with the less, the one that produces less is always the correct ratio. So the one that has the least amount of product. So this is my true one. How many bicycles can be made with 4 wheels and 6 frames? 2. I have to discount this one down here because my limiting reagent is wheels. Okay? Make sense? And I have 4 excess frames. So try this one, guys. Yep. So we have to set up 2 different amounts, 2 different BRPs. We have to set up one with 6 moles of hydrogen, one with 4 moles of N2. We have to do 1 for each reactant. You can actually even do 3 if there's 3 reactants or 4 reactants. You'd have to do 1 for each. So what you have to do is take a look at this. The first one with 6 moles of hydrogen. The second one with 4 moles of nitrogen. So the top table up here, we need 2 moles of nitrogen to produce 4 moles of ammonia. The bottom one, we need 12 moles of hydrogen to produce 6 moles of ammonia. So which one is going to be true? Destiny, you can keep your head up.
The top one, like you said.
The top one. I can only make 4 moles of ammonia. and I'm going to have 2 extra moles of nitrogen because I have extra nitrogen.
Mr. Gilmore, on this slide, can we label what is the excess reagent and what is the limiting reagent?
Yep. So
Make sure you put this in your notes, guys.
Yes, sir.
What Mr. Gilmore's about to write.
Yes, constant very close.
you know what? I gotta.
Oh, you're still with Ben.
I have to recalibrate it.
Oh, insert computer.
Mm-hmm.
Series.
So this here is our limiting reagent.
H2 is your limiting reagent. It's got to run out first, right? And then, what do we call it?
And then N2 is my excess reagent. Excess means there's left over. So like, think about it this way, guys. If I'm making some grilled cheese sandwiches, and I have a whole loaf of bread, but I only have 1 slice of cheese, how many sandwiches can I make? I can only make 1. What do I have excess? I have excess bread. So I just have leftover bread. It's still there, but I'm not going to use it all. I'm not going to put 20 slices of bread in 1 grilled cheese sandwich. That's ridiculous. Just as ridiculous as making 6 moles of ammonia with only 6 moles of hydrogen. Okay? So, Gus, you want to add something?
No.
Okay. So, guess what, guys? You guys need to do this one recording. All right. So the key thing here, guys, is we have 2 different amounts of reactants. We have 4 moles of CH4, 10 moles of O2. So we have to set up 2 BRPs, 1 for each reactant, like we said before.
That's what we're just doing.
So we got to fill this in. So we have CH4, 2O2, 2H2O, CO2. Got to do this twice. So I have my R is going to be the same, 1, 2, 2, 1. Same reaction, but different amounts. So we'll do 4 moles of CH4. No, I'll switch that color. We'll do this in green. 4 moles CH4. And let's figure this out. So 4, what's this going to be? 8, 8, 4. Good. And 10 moles of O2. I have, let's do purple. 10 moles of O2. I have 10, 5, 10, 5. So now we have to make sure we answer the question. My question is, how many moles of water can I make?
You can make about 10.
How many can I make?
18.
Can I make 10 or 8?
8. 8's the right one.
This is correct. This one, I'm done. Why? Because oxygen is my limiting reagent.
Label that too. When we ask you about limiting or excess reagent, we're asking what reactant is running out first for the limiting reagent.
So my limiting reagent is oxygen. My excess reagent is methane. Methane, right? Yeah.
Completely different.
Methane? Methane's natural gas.
No, they were thinking.
Oh, the other methane. So